So here is the first example of a super cool topic of optimization, which is just a fancy way to say, well, uh, what is the best possible answer for a given situation? Well, let's start this example and let's figure out the meaning of it, the proper meaning of it on the way. So it says a ball is thrown in the air. Its height h at any time t is given by the expression h of t equal to 5 times t times 4 times t. So, and the question is placed here. What is the maximum height reached by the ball? Well, pretty much. So h of t represents the height of the ball. So if I input any value for h, let's say I input h of 1, for instance, would be 5, 1 times 4 minus 1. So this would be at the end 5 times 3. And here we got a 15 as an answer. So my point here is that if I input any value on h, or almost any value, we will get something in return. It would be a height. It would be 15 meters, for instance, height. So what if I say, well, let's input, I don't know, a2, about a2. Well, would be 5 times 2 times 4 minus 2, and this will produce 10. 10 minus, 2. So this would be equal to 20 meters. Now, this is higher than the previous 15. So I would say, well, why not let's input a 4, because we have requested to find the maximum possible height, maximum height reached by the ball. So, but we could be trying and trying and trying. And, this is a very simple case. We inputting the 4 in the formula, we get this would be 20 times 0. So this would be equal to 0. Now, the ball in this case would be reaching the ground level again. That would be the meaning of it. But the thing is, we could be trying all along for a long time. Maybe this is not so complicated. Maybe we can figure it out by just trying a bunch of times and figure it out, the shape of it. Or maybe we can use some other tweak. But there is a very nice way using derivatives to figure out the best possible answer for many situations. So in this case, I'm going to pick this expression, the h of t, and what I'm going to do, I'm going to do everything that we have done previously regarding looking for the critical points and figure out whether this represents the height, and we can find a highest possible point for this expression that will be finding actually the answer for this question. So I'm going to take the derivative, but first I think I'm going to do something else first. I'm going to multiply these guys because I think it would be simpler just to multiply these three. Would be 20 times t. I think this is simpler rather than just taking the product. Sometimes something just simpler is just to multiply stuff. So this would be h of t equal to this expression. So we're going to take a derivative out of it. We take derivative 20 times t, that's only 20. Will be minus derivative of 5 times 2, that will make it 10 times t. Well, if we are looking for a critical point, looking for a maxima, then we should equalize this to 0. Be 20 minus 10 times t. Then we got to find this critical point. So of course this is a simple one just for warming up. 10 times t equal to 20. So t would be equal to, at the end, when divide 20 over 10, that would be equal to 2. So this is 2. This should be properly saying, well, 2 seconds. We're just going to leave it at 2 just to avoid any further, complications. So this would be a time t where we have a possible, critical point. Critical point at time equal to 2. I'm going to write critical point. So we got to test this guy. So I'm going to test it just like we have done, just to figure out whether it is a maxima or not. Of course, this is a very simple case. I'm very likely you've already figured out that this is actually going to be a maxima. But I'm still going to prove it. So I'm going to test h prime, let's say, why not, h prime of 1. Why not 1? So we'll be then substituting the 20 minus 10 times 1. So this would be equal to, at the end, 20 minus 10, that will make a positive 10. So here we found that this function would be ascending, and then it reached the t equal to 2, and that would mean we have to do another testing. Let's say we pick h prime of 3. It will be 20 minus 10 times 3. That will be 20 minus 30. That will be negative 10. So this is telling us that after t equals 2, the function starts descending. Descending. There it is. So this is telling us by that this function, that it starts ascending and then starts descending, then this has to be a maxima. This is a maxima. Now, this is with the times equal to 2, then this ball will reach its maximum height, but this is just the time. We need to figure out the height. So in other words, we got to do a substitution. We got to evaluate on this function h to figure out where is going to be this maximum height. So to find the maximum height, evaluate or substitute, evaluate at h of t with t equal to 2. It's a very ugly t. So t equal to 2. So I'm going to do that. Well, let's substitute. The h of 2 will be 5. I'm going to actually substitute on here the multiplied version. I just think, well, it should be simpler, although this is a simple expression. 20 times 2 minus 5 times 2 squared. So we evaluate this will be 20 times 2 will be 40. There will be minus 5 times 4. So will be 40 minus 20. Well, this will be equal to 20 meters, which actually we just tried it here, but just this will be out of luck in this case. But now we are absolutely sure that when the ball after 2 seconds, the ball will reach actually its highest point, and that would be actually, I'm going to frame it. This represents the maximum height reached by the ball. So I'm going to say reach by the ball, and that will be it for this example. I'm just going to write this properly.